16th, 2019. All right, so we are going to be finding the future value of this RESP. And we have to break it into two parts. We have to address the part that is the 3.6% compounded semi-annually from this time to this time, April 16th to July 16th. And then we have to take that amount and transfer it into 4.1% compounded quarterly until the date of December 16th, 2019. All right, so let's start off with what we know. We know that we have a present value of $5,000. We know for this first step that our interest rate is 3.6% and that it is compounded semi-annually. What we don't know is the time. And again, we're going to count to the nearest month because we're dealing in compound interest. So we're just going to go from the 16th to the 16th. All right, so we are starting on April 16th, 2018. And we have to count to July 16th, 2019. So the first thing we need to determine is what comes first. Does April come first or does July come first? And April comes first. So we can count for a full year to April 16th, 2019. So we know that we have one full year. And from there, we can count up by the months to July 2016. So we have May, June, and July. Here's our July 16th, 2019. And again, remember that when we're counting the months, that we are counting the spaces between. So we have 1, 2, 3 months. So we have 3 months. So we know that our time for this first step is 1 year and 3 months. All right, so we can use our compound interest formula, which is F equals P, 1 plus I over M to the MT, and we can solve for the future value by substituting in our values. M is 2, and our time is 1 3/12. And again, I'll just take a moment to clean up what is in the brackets. And perhaps simplify down my exponent. And then I can find my first future value. Of $5,228 and a bunch of cents. Now we are not at our final answer. So it's very important that you don't round this answer, that you keep all of the decimals, because this future value becomes our present value for step 2. And I'm just going to write this. So this future value becomes our P for the next step. All right, so we need, I just want to write down what we know and what we need. We need, oops, maybe I'll read it. We need to take a present value of 5,228 and a bunch of cents to December 16th. So we're going from July 16th, where we ended 2019, to December 16th, 2019. So we need to, that's our time duration. Our new interest rate for the second step is 4.1%, and we are compounding quarterly. All right, let's find our time interval from July 16th of 2019, and we can see that we are in the same year, so we're just going to have to count up to December. So July, August, September, October, November, and now we're at December 16th, 2019. And again, because we're counting months, we are simply going to count the spaces between. So we have 1, 2, 3, 4, 5 months. All right, so now we have everything that we need to solve for future value 2, or our second step calculation. It's equal to P1 plus I over M to the MT, or 50 to 28.046592. 1 plus our interest rate is 0.041 over 4 to the 4 times 5/12. And perhaps I will just again take a moment to clean up this step. You are more than welcome to punch this right into your calculator if you wish, but for the purposes of this note, I'll just clean this up. Really important that you don't lose any decimals in this process. So this is just 20 over 12. All right, so now we're ready to find our final answer, and our final answer gets rounded to 2 decimal places. And so the future value after those 2 interest rate changes are $5,317.66. All right, so let's move along to some other types of problems that have multiple steps in them. I'm just going to move past this example of Barbara, but I do want to focus in on example 6 that talks about a savings account where we're adding money in. So it says Jaden opened a savings account with TD Bank on February 5th, 2017 with a deposit of $1,400. He added $2,100 on June 5th, 2018 and another $1,600 on September 5th, 2019. What will his account amount to on August 5th, 2021 if the plan earns a fixed rate of interest of 1.2% compounded semi-annually? All right, I'm going to suggest to you that anytime we are adding or subtracting that we need to stop on our timeline. This, my fine folks, is something called the banker's method. So let's take a look at our timeline. Let's just get a rough picture of what's going on. It's not terribly accurate. We're going to have to determine what each of our time intervals are between, but we're starting on February 5th, 2017, and Jaden has deposited $1,400 into his bank account. And then sometime in the future, on June 5th, 2018, he has added in $2,100. And then on September 5th, 2019, he has added in another $1,600. And we want to know, if he has done these three things, how much money will he have on August 5th, 2021? How much will he have in the future if interest is 1.2% compounded semi-annually? All right, so I just am happy about the fact that we have a constant interest rate, so we don't have to worry about that changing at all as we go along. So all of our calculations are going to have an I of 0.021 and an M of 2. And that's nice for us. So what's our plan of action? Well, we're going to take this $1,400 into the future, and we're going to find future value 1. And we're going to stop because clearly we are adding some money into the account. And when we stop, we're going to add the $1,200. And once we've done that, then we're going to move that money into the future and find future value 2. And we're going to stop again and add the $1,600. And after we've done that, we're going to move that money into the future and find future value 3. So this is a 3-step calculation, and each of our calculations are going to have this constant interest rate and constant compounding period. So we're going to need to find the time interval in between each of these specific dates. All right, so we could start with the time between February 17th, 2017, February 5th, 2017, and June 5th, 2018. All right, so clearly we can count from February to February. Because there is one full February cycle. So we have February 5th, 17 to February 5th, 18. And now we can, from February 5th, we can count up to June. So February, March, April, May, and June. And we can see that our time interval is 1 full year. And then how many spaces do we have? We have 1, 2, 3, 4 months. And then we can count from June 5th to September 5th. Again, we have a full year cycle from June 5th, 2018, to June 5th, 2019, and then we can count up to September, so June, then we have July, August, and now we're at September 5th, 2019, and so we can count 1 full year again, plus 1, 2, 3 months. And lastly, we can take care of the final timeline from September 5th, 2019. So this one, we can see that August is the month right before. So if we go September 5th, 19, September 5th, 20, and then September 5th, 21, we can actually work backwards this time, and we can count that it's 1 month less. So we can say that our time here is actually 1 full year and 11 months. All right, so now we have all of the information that we need for our calculations. So we're starting with future value 1. And again, we know that we're using this formula. So we're starting with $1,400, and we're moving that forward at a constant interest rate of 1.2% compounded semi-annually, and our first interval is 1 4/12. And we're going to find that answer, and because we've stopped, we're going to add in our deposit, which is $2,100. All right, I'm just going to punch this in one swoop into my calculator. You are welcome to break it into steps if you wish. And I get a final amount of $3522.512149. All right, so now I know that this is where I'm sitting. I'm right here now with future value 1. And now I need to move that forward in time, where this amount of $3522 becomes my present value for my next calculation. So future value